Okay, so let's look at this example. As of April 2021, the national debt was 28.1 trillion or 28.1 1.10 to the power 12. As you can see here, 28.1 trillion can also be written as 28.1 times 10 to the power 12 because there are 12 zeros in trillion. So this notation, as you can see here, this is called a scientific notation. So in this section, we're going to talk about exponent and scientific notation. Sometimes what happens is we might have very huge number, and then instead of using all those zeros, we try to write down those numbers in different notation, and that's the scientific notation. Whenever we try to express numbers in scientific notation, we also have to be careful with the exponents and the rule of exponents. So in this section, our objective is learn about the properties of the exponent and convert the scientific notation to decimal or decimal to scientific, and then do some application problem. That was first example I was giving you as an example, which is applied in our day-to-day life. So let's look at the properties of the exponent. Whenever you have the same base, uh, you can just add the exponent, and then that's how you can simplify. That's called product rule. This is called multiplication of the two exponents, two exponential expression with the same base. This rule doesn't apply if you have different base. Here is the one example. Let's say you have 9 to the power 6 and 9 to the power 12. You can express them as a 9 to the power 6 plus 12, and which is a 9 to the power 18. There is a second rule that's called the power rule, which is power to the power. Actually, whenever you have the power to the power, it's just the multiplication between the exponent. One of the example is 3 to the power 4 to the power 5 is actually 3 to the power 20, because if you multiply 4 and 5, that gives you 20. And then division or the quotient rule, if you are dividing b to the power m, which is the same base, by b to the power n, and then actually we're just subtracting the base, the exponent from the denominator from the exponent of the numerator. So example is 5 to the power 12 divided by 5 to the power 4 is actually 5 to the power 12 minus 4. So these are the properties of the exponent. There is one very useful property that's called zero exponent rule. For any real number to the power 0 is 1. For any real number except 0 itself. So let's see, if you have 1 to the power 0, that would be 1. If you have 5 to the power 0, that is also 1. But if you have 0 to the power 0, this is the type of the number which we don't know the answer in math, so we say indeterminate form. So this rule only applies if you have other than 0. Negative exponent rule. Normally what happens is we don't express a number as a negative exponent, so we try to change that exponent to the positive by changing the position of the base. If the base is on the top, we bring the base on the bottom and then make the exponent positive. Example is, let's say you have 2 to the power negative 3, then you can write it down as a 1 over 2 to the power 3, which is 1 over 8. Another example is, let's say you have 5 to the power 2 to the power negative 7. Then by changing the position of the base, we can bring this base to the up, and then we can only do that by changing the sign of the exponent. That's the negative exponent. So sometimes expressing numbers as a 10 to the power power of 10 is very useful. For example, let's say you have this number, which is 1 billion. 1 billion also can be written as 1 10 to the power, how many zeros are there? 9 zeros. Okay, and sometime, as you can see here, if the power is negative, then we can write down that as a point. And look at here, 1 2 3 4 5 6 7 8. Because there is a 9 negative exponent, you have the first one after 8th position, which is the 9th position. So 10 to the power negative 9 is the one goes here. Let's say you have some other things. So 10 to the power negative 5, then you start with the decimal sign, and then you put 1 2 3 4. Fifth position would be our first number. That's the power of tens. Scientific notation means if you express any number in this form, that's called scientific notation. Keep in mind, we try to express a in between 1 and less than 10. So let's say you have 5, 50, 1, 2, 3, 3 power. Then as a scientific notation, we just write a number which is less than 10. Here in this case 5 is less than 10 times 10 to the power. How many zeros are there? 1, 2, 3, 4 zeros. Let's say if you have 51 and then 3 zeros, then because we try to express scientific notation as a number less than 10, so instead of 51 we have to write down 5.1 times 10 to the power. How many position we are moving here? You have to start from the second one. 1, 2, 3, 4. So you have to write down 4. Okay, that's called scientific notation. There is a rule to convert scientific notation to the decimal notation. If n is positive, move the decimal point in a to the right n places. For example, let's say you have 5 times 10 to the power 2, then you have to move the decimal point in a to the right n places. Here is no decimal. Let me just use 5.1. So 5.1, we don't want this decimal, so just copy 51 and move this decimal right side to the right n places. 1, this is 510. So after decimal there is a 1 number and here is a 10 to the power 2, so there will be 2 more zeros. 1 0 is for this one and another 0 is already here, so 510. So the meaning is we moved this decimal 2 points to the right, 1 and then second one is 0, so this decimal comes here, the decimal comes here, and then after decimal there is nothing. That's why we don't have to write down that. It's just 510. Okay, for example, let's say you have 5.3410 to the power 2, then this decimal move 2 position because there is a power 2 here. Okay, if you have a negative exponent, then move the decimal to the left side. For example, let's say you have 55.5 10 to the power negative 2, then you move the decimal 2 places to the left side. So 1 place, 2 place, so that decimal comes here and it becomes 555. That decimal moves to the left side if you have a negative exponent. But if you have a positive exponent, that decimal move to the right side that many position. This is the rule for converting scientific notation to the decimal notation. And now if you want to convert the decimal to the scientific, then our goal is to write down the number in this form. Okay, in this form. So first of all, we need to determine a, the numerical factor, move the decimal point in the given number to obtain a number greater than or equal to 1 and less than 10. So that is how we can change decimal to the scientific notation. For example, let's say you have 0.34. We would like to write down this as a scientific notation. So first of all, find out which number is less than 10. So the first position, 5 is less than 10, so write down 5 and then move this decimal to the left side. As you can see here, if I write down 5.534, so how many position I move this decimal to the left? That goes here, 10 to the power 1. I just moved 1 time, so that's why it goes to the power would be 1. So let's say you have 534.23, then I can write down, starting with the just one number which is less than 10, and then I move this decimal to 5.3423. How many position I move this decimal to the left side? 2 position. That's why the 10 to the power is 2. Similarly, if you have a negative, then determine n, the exponent on 10 to the power n, the absolute value of n is number of places. So if it's a negative, then you just do the opposite. You go to the right side. For example, let's say you have 534 point 34. Yeah, this is not the right example. Let's say you have 0.534. I would like to express this as a scientific notation. Then first of all, I need a number. In this case, that's the first number, which is 5 times, so I 5.34. You just need a number which is less than 10. So 5.34 would be less than 10. But to do that, we move this decimal to the one side right to make sure that we have the right scientific notation. Because we move the decimal to the right side, we need the negative sign. So negative, how many position? One position. So 10 to the power negative 1. For example, let's say you have 0.0534. Again, your number is supposed to be 5.34. And to do that, we move this 5 1 2 position to the left. This decimal goes to 1 2. After 2 position, we put the decimal. So that's the reason it would be negative 2. So you just count how many times you move the decimal to the left, to the right, to write down the number in scientific notation. You put that thing in the exponent as a negative exponent. If you move that number decimal to the left, then you express your scientific notation as 10 to the power number of position as a positive exponent. Okay, so let's say you have a two number with a scientific notation. Let's say a times 10 to the power n and b times 10 to the power m. Then you just multiply a and b, and whatever number comes, it's supposed to be less than 10. If it's greater than 10, you have to take care of the sign here. But at this point, if a times b is less than 10, then just multiply that and 10 to the power n plus m. You just have to use the property of exponent. For example, let's say 3 times 10 to the power 2 is one number, and another number is 2 times 10 to the power 3. Then you have to multiply 3 and 2. That will give you 3 times 6, and 10 to the power 2 plus 3 is 5. But let's say if you have a 5 here, 10 to the power 2 times, and here 6, 10 to the power 3, then what is 5 times 6? It's a 30. 30. But we don't want to write down the final product as greater than 10, so we just put 3.0. So we put one extra decimal here, and now whenever you try to add 2 plus 3, which is 5, because there is one decimal here, that will give you one extra 1 on the exponent. So that would be 2 plus 3 plus 1. So we put decimal sign, one decimal sign here. The decimal, after the decimal there is one number. That's why we put one extra here. So this multiplication would be 3 times 10 to the power 6. Originally it has to be 30 times 10 to the power 5, but we cannot express 30, this number, as a greater than 10, so we have to make it less than 10. How do you do that? By putting decimal after the first digit, which is 1 place. That's why it becomes 6. You have to increase the exponent here. Okay, similarly, when you divide a scientific number by another scientific number, the same rule applies. This is the example I was talking at the beginning. So this is one of the application example where 28.1 trillion can also be written as 28.1 times 10 to the power 12, which is not exactly the scientific notation, and 331 million can also be written as 3.31. So this one here, if you have to, the question is if the national debt was evenly divided, so you have to divide this number by this number. So it would be 28.1 divided by 3.31, and then there is a 10 to the power 12, and here is how many zeros? It's a 331, 1 2 3 4 5 6, and we put the decimal here. After decimal, how many digits are there? 6 7 8. So it would be 10 to the power, 10 to the power 8. So let me just write down 10 to the power 8 here. So now when you divide 28.1 by 3.31, you can use the calculator. And then here for the division, so let me just use the calculator here. So 28.1 divided by 3.31, that is 8.489. So I can write it down 8.49 if I have to approximate to the two decimal place. But that depends on the problem. If it asks you to approximate, then we have to approximate, otherwise we don't. And then what about this thing? It would be 10 to the power 12 minus 8, which is 4. This is final answer is the in scientific notation. Okay, let's look at some example from the homework problem here. Okay, express the following number in decimal notation. 9.6 times 10 to the power 5. So to write down this number as a decimal notation, for it's already, it looks like a decimal, but it is not, because it's a scientific notation. We have to convert that to the decimal notation. Let me just insert a couple of blank pages here, and then let's do the problem. 9.6 times 10 to the power 5. So in the decimal, it means you have to move this decimal 5 position to the right. 9 6. So 1 2 3 1 2 3 4 5. So if you don't have the digit here, then you just add extra zeros. So it would be 960,000. That's in a decimal form. 960,000. Okay. The distance between two planets is over 81 million miles. So remember, this is an application of this topic, whatever we're discussing here. We would like to write down this distance as a scientific notation. So first of all, think about this. 81 million has 6 zeros after 81. So we would like to write down this as a scientific notation. So scientific notation means you have to start with the first digit, which is supposed to be less than 10, and then after first digit you have to put the decimal, and the number of zeros you don't have to write down that, times 10 to the power. So we place the decimal after one digit. So how many digits left over? 1 2 3 4 5 6 7. It's 10 to the power 7. So it's 8.1 times 10 to the power 7. Let's go to next problem. Determine whether the statement shown below is true or false. If the statement is false, make the necessary changes. A trillion is 1 followed by 12 zero. So billion means 9 zeros, trillion means 12 zero. That's the true statement. Let me just do one question. It's the division of scientific notation. So first of all, we have 15 times 10 to the power 7 divided by 3 times 10 to the power 3. Divide 15 by 3, that would be 5. If it's greater than 10, then we have to follow the rule to make it scientific notation, but it's already less than 10, so we don't have to worry. Now we just have to take care of this part. 10 to the power 7 divided by 10 to the power 3, that is 7 minus 3, which is 5 times 10 to the power 4. That's a scientific notation. 5. Type an integer or decimal. Okay, we don't want to express the answer in scientific notation. We would like to express the answer in decimal form. So that means we have to write down this as a 5. And how many zeros we have to add? 1 2 3 4. Okay, that's 4 0. So you have to read the instruction to put your final answer. What is happening here? Type an integer or decimal form. Perform the indicated computation and express the answer in decimal notation. So that would be, sorry, it's not 5. If you divide 5 by 3, no, here it's 5 divided by 5, 15 divided by 5, it's not 3, my bad. 15 divided by 5, which is 3. So instead of 5, we're supposed to have 3. My bad, I didn't pay attention here. Other than that, everything else is good. Let me do one more question. For a certain country, the national debt was 15 trillion. Remember, trillion means after 15, there's supposed to be 12 zero. use scientific notation to put a number like 15.00 trillion in perspective. Complete the answer. So scientific notation, so 15 trillion. So after 15 we supposed to have 15 and then 10 12 0 1 2 3 4 5 6 7 8 9 10 11 12. If you write down, if you want to write down this number as a scientific, then you can only use the first digit and you have to put the decimal after the first digit. For the zeros, you don't have to write down after the decimal thing. You just have to count how many digits are here after decimal. 1 2 3 12 and 1, so 10 to the power 13. So it would be 1.5 times 10 to the power 1.5 10 to the 1.5 10 to the power 13. Okay, 4 years of tuition fees and room and board at public US college cost approximately 70,000. So how do you write 70,000 as in scientific notation? Just write down 7.0. There are all the zero digits, so you don't have to write down that. 7 times 10 to the power, how many zeros? 4 zeros. So 10 to the power 4. Use your answer from part A and B to determine how many citizens could receive a free college education for 15 trillion. So the college 4-year tuition fees is 7 times 10 to the power 4 dollar. And how many? You have to divide A by B. That means you have to divide 1.5 10 to the power 3 by 7 times 10 to the power 4. You can do this. Remember, 1.5 divided by 7 is 1.5 divided by 7. It's a decimal number. Sorry about that. 1.5 divided by 7 is, one more time, let me start. 1.5 divided by 7 is this number, and then if you simplify this, it would be 10 to the power 9, because 13 minus 4 is 9. So we would like to write down this as a scientific notation. So but for the scientific notation, number is supposed to be greater or equal to 1 and less than 10. So we have to move this decimal to the right 1 point. So it would be 2.14 10 to the power 9, because 13 minus 4 is 9, but because we move this decimal 1 place to the right, so it would be 8. We moved 1 place to the right, so that would be 1 less than 10 to the power. You also have to read the instruction, type your answer in scientific notation, use the appropriate symbol from the math here, and then round to the 2 decimal place. I did not round it to the 2 decimal place. It's supposed to be 2.14. Yeah, that's right. 2.14 10 to the power 8. 2.14 times 10 to the power 8. Okay, so that is the number of citizens. The answer to part C in decimal notation is, in decimal notation, it would be, you just want to write down 2.14 and move this decimal 8 places to the right. 2, if I move this is 2 position, and then for the rest of the position, because there are no digits, you have to put extra zeros. 1 2 3 4 5 6 digits, and then 2 digits, so altogether it's 8. Okay, that's all for this section.